Right, hello 11 Sharman. I just thought I'd give you a lesson today, so you hear a teacher's voice. Dr. Patel is going to be off again this week, so I thought I'd just say you something. Nothing too challenging today. I'm just going to give you a little lesson starting a topic called chemical analysis. Chemical analysis, we're moving on now from organic chemistry, which you've been doing with Dr. Patel, and that was all alkanes and things like that, and crude oil. So this is a separate topic, and I feel like if I set you some stuff from this, it's not going to, you might end up going back and doing some of the organic chemistry, the crude oil stuff with Dr. Patel, but I thought this is quite an easy one to start. So all I'd like you to do, please, is watch through this little lesson. There will be a keyword, so like hidden somewhere in this lesson to prove that you've watched this lesson all the way through. Okay, so keep your ear out for that keyword, and yeah, we'll see how you get on. So chemical analysis. Then we're going to start off in today's little small lesson. We're going to be looking at what the terms pure and formulation mean in terms of chemistry. Okay, so you might think, well, that sounds quite an easy thing to do. Well, we're going to start off with this word pure. So in chemistry, a pure substance means only a single substance. So it can be a single element or a single compound. So what I mean by this is if you had a beaker of pure water would be entirely made of H2O. In other words, there would be nothing else in that water at all. So pure water is just H2O. The water you get from your taps is not actually pure water. Inside your tap water, you get things like a little bit of chlorine, which is put in by the water board to kill germs. You get a little bit of fluoride, which is designed to make your teeth a little bit stronger. And you also get some bits of other chemicals dissolved from maybe through the pipes that the water has travelled through, or the rocks that the water has travelled over. So the water that you've got in your taps is not pure water. We do have pure water in school, and we use it quite a lot at A level. We use pure water. You can drink pure water, but it's not recommended that you drink too much of it. Okay, it can actually cause you some harm. So other examples of pure, you can have things like pure gold. Now, pure gold, if you had a lump of pure gold, it would be made entirely of gold atoms. If you were to zoom in on this, it would be 100% gold, and the symbol for gold is AU, 100% gold atoms. If you had any other atoms in there, it would not be pure gold. So the word pure in chemistry really has to be, it's very specific. It means you are made of one type of things only. So pure water is 100% H2O, and pure gold is 100% AU. So this is different to our general everyday language for pure. So I know for a fact that some people in everyday language might say, you might go, I've got a glass of pure milk, for example. No. So as a chemist, if somebody says to me, I've got a glass of pure milk, I know what they mean when they say pure milk. It just means milk. But you cannot have pure milk as far as a chemist is concerned, because I know that milk is actually a mixture. It is not pure. It is a mixture of oils and fats. It has got water in it. It has got calcium in it. So milk is not a pure substance. It's actually a mixture. So the opposite of pure, the opposite of pure would be a mixture. You can have mixtures of substances are not pure. So it's perfectly fine in your everyday example to say pure milk or pure water, but in terms of chemistry in your GCSE, you need to be 100% sure that pure is 100% one substance. Okay, so I want to show you something now. Where have I got it? I'm just going to pause the vid. Alright, so I'm back in the room. I just went to find this. This is, wasn't on my finger because I've been doing some DIY work. That's my wedding ring. So my question to you is, do you think this wedding ring is pure gold? Alright, is that a pure substance? And the answer is, no, it's not. Most metals are in fact not pure. Pure gold, 100% gold atoms, would be really, really soft. And as you can see, this ring, I can't bend it. So this is actually a mixture. And a mixture of metals is actually known as an alloy. So most substances that we use in our everyday lives are not actually pure. I can't really think of many things that we use that are pure. Right, how does a chemist then tell whether something is pure? And there's this little rule here. Pure substances have fixed melting and boiling points. Pure substances have fixed melting and boiling points. So this is what I mean by that. Pure water. Pure water melts at 0 degrees C. That is the melting point of pure water. So if you have 100% water, guaranteed that if you take that and you have ice, pure water ice, that ice will start to melt at 0 degrees C. And its boiling point is 100 degrees C. These are fixed. These are scientific facts that pure water melts at 0 and it boils at 100 degrees C. If you have water with something dissolved in it, so maybe some salty water, so salty water is not pure water, is it? So water with something in it. What you get is you get a melting range. So you will find that instead of melting at 0 degrees C, it might melt at maybe -2 degrees C. And instead of boiling at 100 degrees C, it might boil between maybe 101 and 102 degrees C. So, the melting range might be between -2 and 0. So you have this range over which it will melt and boil. So pure substances have a boiling point. And when I say point, I mean an exact number. Whereas if you make a mixture, you'll get a melting and a boiling range. So it'll start to melt between -2 and 0. It will start to boil at between 101 and 102. And the exact numbers where these happen depends on, for example, how much salt you have in your water. This is quite a useful technique, really. And it's one of the reasons, a useful scientific fact, sorry. It's one of the reasons we put salt onto roads when it's icy. Because if you put salt onto roads when it's icy, the now salty water will melt at a lower temperature. So if it's -2 degrees outside, the ice will actually turn into water if you've put salt on it. Whereas pure water will still be icy at -2. So the key point here is, again, just to reiterate, pure substances have a boiling point. Pure at a point. I'll give you another example. Salt. The salt that you put on your chips, which is sodium chloride. Sodium chloride, it melts at 801 degrees C. So pure salt melts at 801 degrees C. Now this is quite a useful fact for chemists. So if I found a white powder on a table and I wanted to find out what it was, what I can do with this is I can melt it, and if it melts at 801 degrees C, I know that it is sodium chloride. I know exactly what it is. So pure substances have these fixed melting points. All right? So that's what pure means in terms of chemistry. Pure is when a substance is 100% pure. 100% water with nothing else mixed in. 100% salt with nothing else mixed in. All right. The next word that I said we were going to look at was this one. Formulations. Now I mentioned this at the start of the video. The key word for today's video is bananas. The key word is bananas. All right, so now we're going to be looking at formulations. Now, a formulation is a mixture which has been designed for a purpose. So what I mean by this is, so first I'm going to start off with some examples. If you were to take some paint, for example, a tin of paint from B&Q or wherever it might be, this paint here will have been made to a very specific recipe by the company that made this paint. They will have taken a mixture of different colours and mixed them together, and they would mix some water in there and some oil in there. So it's a very specific recipe. So I know that if I was going to paint my room with this paint and it ran out, I could go to the shop the very next day and buy another tin of paint, and it would be the same, because I know that this mixture has been followed, they have followed a very specific recipe. There is a factory making exactly this paint using exactly the same recipe. And in chemistry, the recipe that they follow to make this mixture is known as a formulation. So we see formulations all over the place. If you take a little paracetamol tablet for a headache, typically paracetamol tablets have got about 500 milligrams of paracetamol in. They've got a little bit of chalk in, which is designed to dissolve in your stomach, and they've got some other stuff. But the point is that you trust that every single paracetamol tablet that you eat is exactly the same. So there is a factory that makes paracetamol tablets and they use the same recipe. That recipe is called a formulation. And you need to know that a formulation is a mixture which was designed for a purpose. So a formulation is a mixture which has been designed for a purpose, using exactly the same recipe or exactly the same amounts of each substance. I'll give you some other examples of formulations. Formulations could be food. So if I wanted to get, see if I can draw a Mars bar. I know that a Mars bar, if I go and eat a Mars bar, it will taste the same wherever I buy it from, whatever day I buy it from and whatever shop. Because in the Mars factory, what they have followed is, I know that a Mars is they have followed exactly the same recipe. This Mars bar is a mixture that has been designed for a purpose. And they stick to that same mixture every time they make a Mars bar. So a chemist would call that recipe a formulation. They have used the same mixture every single time. I'm going to show you what this looks like in the book. This is my notebook. A formulation is a mixture that has been designed as a useful product. So I've said this could be a Mars bar, this could be some paint, this could be some medicine. Many products are complex mixtures in which each chemical has a particular purpose. So in that Mars bar, they've mixed lots of things in. They've mixed chocolate, they've mixed sugar, they've mixed things called emulsifiers, they've mixed fat, they've mixed water, and they all have a particular purpose. If they missed any of those ingredients out, you would be able to taste it. Formulations are made by mixing the components in carefully measured quantities. So going back to that Mars bar factory, they don't muck about with their measurements. They measure their cocoa powder and their milk and everything to the nearest milligram. They carefully measure it because they want their Mars bars to taste exactly the same each time. They want the paint in the paint factory to be identical every single time because I don't want to paint half of my house one shade of blue and the other half a different shade of blue because they didn't measure it properly. So what we call one of these carefully measured out mixtures is a formulation. I want you to realise that that's the only thing I'm trying to teach you here. There is a word for a carefully measured out mixture is a formulation. Formulations include fuels. So when you put petrol in your car, that is a carefully measured out mixture of different fuels. Cleaning agents, so soaps, bleaches and things like that, are a carefully measured out mixture, a formulation. Paints, medicines, alloys like the metal in this wedding ring. Fertilizers. So if I go to again, B&Q or whatever, and buy a big bag of fertilizer for my garden, a huge sack of fertilizer, I know that in the fertilizer factory, so maybe I'll draw some leaves on that. In the fertilizer factory, they will have carefully measured out all of the different chemicals that my garden needs. And I know that every time I buy a bag of fertilizer, they will have carefully measured it out. So that is called a formulation. All right, that's it. That's the lesson. Now, I could have given you a video on that was just linked to a YouTube, but I thought you might want to hear a familiar voice. Hello to everybody there. Hello to members of my form. Hi, Cameron. I just wanted you to hear a familiar voice, but really, there's nothing massively important to get from this, massively difficult, to get from this. It is important. So what have we gone through again? Let's see the whole lesson. We said today, where's my first sheet? Today we would be looking at the words pure and formulation. Pure is 100% single substance and you have a boiling point. E.g. pure water, boiling points. If you have a mixture, you get a boiling range. I then wrote pure substance, boiling point. I then gave you a little example of how you might use that. If you know the boiling point of something and you find a chemical and it has that boiling point, well, that means you can identify that chemical. So that was pure. Then we went on to formulations, and formulations are mixtures, but not just a random mixture. It's a carefully measured out mixture that serves a job, that does a purpose. And we said things like paint and medicines and food and fertilizers and fuels are all examples of formulations where they've been made in a factory to a very, very specific recipe. So that word, formulation. So today, pure and formulation. There was a keyword hidden in that video. You're going to have to watch back to find that keyword, and I will let you know any tasks that are associated with this little video. I hope that's all right. Gives you something to do for 20 minutes, that, and I'll be in touch soon.